The next speaker is Mr. Johan Euphrosine.
So yeah, I also want to introduce Shigeta-san. Yeah, so I want to introduce Shigeta-san, who's working for University Relations. He's going to do the whole other half of the talk. So yeah, I don't already did my introduction, so I can skip time. So yeah, so I joined the hardware toolchain team 1 year ago, and I come from a software engineering background, so I had nothing to do with silicon and nothing to do with hardware. But the team vision really seduced me, like to produce a coherent toolchain, like where a software developer and engineer, and hardware engineer can co-design hardware together and co-design custom silicon together. And so think of it as if you add like an optimization flag for GCC that allows you to choose like this part of your code that you want to do in custom silicon. That's like the vision that our team started with. And we figured out that in order to do that, we need an open source silicon ecosystem. But there was like 4 missing pieces that we identified at the time, like 2 years ago when we started this project. So it's those 4 pieces are listed inside a paper that we sent to ICCAD in 2020. And we identified that for an open source silicon ecosystem to appear, we need an open source PDK, an open source silicon toolchain, open source IP block, and cheaper and faster manufacturing option. So a lot of things had to be done like 2 years ago to make that happen. And like this talk is about what we try to contribute here as Google as a company, the challenge that we found, and the lesson that we got out of that. So it's a little bit of a retrospective of our journey toward an open source silicon ecosystem. So first, like starting with the PDK. So we partnered like with 2 foundries. So the first one was Skywater 2 years ago. So we managed to convince them to open source their 130 nanometer process node. So it's a fairly mature node. So it's like around like 15 to 20 years old. But it's like totally fine for starting to design chip. And first, it was the first like even open source PDK that was manufacturable, meaning that the open PDK is on GitHub. It's under Apache 2 licenses. You don't need any NDA to download it and to study it, to look at the standard cell and to start doing your design. And doing 1 year, after releasing that PDK, we got in touch with a global foundry and we managed to convince them similarly to open source their 180 nanometer PDK. So for us as an ecosystem, this was very important because like we went from 0 to 1 first, but then from 1 to 2. And the step from 1 to 2 is almost as important as the step from 0 to 1. Because all the tools now that had to figure out a way to support 2 PDK, all the people that designed IP against Sky 130 had to find a way to port them to Global Foundry 180. And so it was a very important step for the ecosystem. And recently, last year, we were super happy to hear that another foundry, IHP, that we didn't have any contact with, decided to open source their PDK on their own. So they open source their PDK for their BIMOS 130 nanometer process. So it's a very good validation that the ecosystem is starting to grow, because now we have foundry that don't even talk to Google and that open source their PDK by themselves under the same license term with like similar packaging organization. And so on top of the PDK, if you want to make a successful design, like you need a toolchain. And like there was a lot of open source tool that were available to do design, but they were like we managed to put them together next to each other into a coherent toolchain along with the community. And so what we really did contribute there as a company was to make sure that those tools were supporting the open source PDK I mentioned before. So we ensure that you could do synthesis, that you could do place and route, and GDS streaming and DRC with those PDK, using tools like YOSYS, OpenRoad and OpenLane, and Magic and Klayout. And at the top of this toolchain, one part that Google also contributed is that we open source like our high-level synthesis toolkit called XLS, which is a tool that's very important for us to make software engineer and hardware engineer work together on a common code base. It allows you to describe the algorithm that you want to accelerate using a software-like syntax, and then generate some Verilog that you can then throw through the rest of the toolchain. And so you can go from a code level description to Verilog to LevDev, then to a GTS that's really ready to support to submit to the foundry. But so if you have a PDK, if you have a toolchain, you still need money to make chips. And like it's costing a lot of money to make chips, and it's not really accessible to hobbyists or even students or startups. And so we partner with one of the pioneers into democratizing of IC a semiconductor startup, which is called IFA Bless. And we put together a program with very simple rule. So the rule was that Google will pay for the manufacturing of the chip, so with no entry cost at all from the people who submit design, as long as their design was open source, using the open source PDK, and reproducible using the open source tool. And so out of all the submission, like 40 design get selected at random, and after a few months, like the wafer is like fabricated, and then you've got like those chips, a dev board, and a little breakout board to test your design. Your design itself has to fit within a 10 millimeter square area here, and on the bottom there is a little RISC-V chip that's here to verify that the design is working. And so we run this program for 2 years now, and we run like around 9 shuttles for accepting submission. And you can see at the beginning, we barely had enough submission for filling the 40 slots. But in the latest shuttle that we ran earlier this year, we had 147 submissions who went over like the 40 slots. And so you can see like a growing interest in the community into taping out chip. And like more than half of the people who participated into this program were first-time designers. And so thanks to the program, we actually accumulated a pool inside the community of more than 750 fully open source design that other people can derive design from. So there is also like a trend here of people like reusing previous people design to the shuttle and submitting a tiny variation to the new one, just like it happened in software all the time, where a lot of people take a library and software library and build a new software out of it. And so out of those shuttle, we see participation from all over the world. So in the latest shuttle that we ran on the GF technology, it was mostly people from United States and India doing almost half of the submission, but we also see people from Japan and people from Europe, Turkey, Egypt. And this program was also not without challenge. Like at the first run that we ran, we had like some design miss inside the RISC-V chip, and we thought that the chip were dead on arrival. But the community together managed to tweak the voltage, the power voltage of the chip, and make them boot and work. We also have like multiple delay around packaging for some of the shuttle run that we run, and we got challenged by the number of submission and pull requests and issue that we got on the PDK, and Google was always kind of trying to catch up to file and merge those issues. But in general, like people are getting their silicon back now and are being successful bringing them up. So here you can see like a small collage of like people picture that people posted online where they received the chip from IFA Bless that they submitted to the shuttle, and they are trying to verify that they are actually working. And like one project I want to showcase in particular is the first project that got submitted from Japan. So it was a tiny 8-bit processor that someone did with the custom ISA. So it's a student from a university that submitted like an ISA that they designed themselves, like a CPU that they designed themselves. And so they received it last week, and they're already like working on their bench to make sure it's works. And so they actually have a presentation outside on the other hall, like right at this time. So I encourage, as soon as their talk finish, to go and catch their talk. And so, yeah, in general, I want to encourage you to join this open source community. It has grown a lot since we started it 2 years ago. There is more than 4,000 people inside the Slack channel, and there is a channel dedicated to Japan called Japan Region. We have a website, developer.google.com/silicon, that's localized in Japanese. And this blog post is going to introduce you to the program and the philosophy behind it. In Japan also, there is a local community that started called Ishikai, and they have a booth outside, just outside that booth. And they're going to have a meetup, an online meetup on July 1st that I encourage you to join. And we also had like a workshop at VLSI 2023, which was a conference in Kyoto last week. And we had very good attendance, as you can see in the room there, like people were standing on the back of the room. So it was a good validation also of that ecosystem is growing. So what is the next step for Google? So we want to help other entities like fab, government, and industry to replicate our success with this program. We want to help them avoid the trap that we found along the way. We want to continue to advance high-level synthesis and enable team, software and hardware team to co-design chips together. And like Shigeta-san is going to talk about quickly, we also want to fund reproducible silicon research. Because when you have an open source PDK, an open source toolchain, and open source design, and it means that you can make research that other people can reproduce and build on top of.
はい、ここからちょっと日本語で、Google の重田と申します。で、大学連携担当をしておりまして、ハードウェアに限らず全般的な Google の研究者とアカデミックの研究連携というところを支援する立場にあるものです。で、先ほどジョハンからありましたように、シリコン系のプログラムに関しましても、リサーチファンディングを計画しておりまして、一応シリコンリサーチプログラムというふうに呼んでおります。で、これなんですけど、アカデミックなところの部分と、ヨハンのような、オープンハードウェアの研究者、もしくはそれ以外の、Google のハードウェア研究者との連携を、支援させてもらうようなプログラムになってまして、それぞれで、それらにとってメリットのあるような、例えばオープンハードウェアを使った、のツールを一緒に開発しましょうというプロジェクトであったりとか、オープンハードウェアのものを使って、作っていきましょうという、何かアプリケーションを作っていきましょうというようなプロジェクトであったりといったものを支援することを想定しています。で、主に、今月から来月にかけて募集をかけようと思っていまして、で、一応公募というよりはどちらかというと、担当者といろいろ議論していただいてですね、こういうプロジェクト一緒にやったら面白いんじゃないかということを、カジュアルに話してもらって、それを提案として持ち込んでいただければ、それを支援していくというような形の仕組みを考えてますので、ちょうどここにヨハンもいますし、私もいますので、ぜひご興味のある方は我々に話しに来ていただいて、何ができるかなというのを一緒に考えられるなと思っております。で、一例としてどんな辺の領域を関心持っているかと言いますと、一つはオープンソースハードウェアというところで、特に、高位合成、ハイレベルシンセシスというところが、一つの関心領域となっています。で、それ以外の部分でも、ハードウェアランゲージその他いろいろ、興味ある部分はありますので、ぜひここは、直接担当と、議論していただいて、どういうところで一緒に研究できるかということを考えていただければというふうに思っています。で、もう一つはですね、皆さんご存知の通り Google Pixel フォン、タブレットといったようなものを、デバイスをいろいろ作ってますので、そうしたモバイルデバイス向けの、研究というのも、台湾チーム中心に、考えていきたいということを考えてますので、こうしたところも関心領域になるかなというふうに考えております。でですね、これを今後どんどん募集を進めていく予定ですので、ぜひご興味ある方はお声掛けいただきましたら、詳細等をご案内させていただきますので、ぜひよろしくお願いします。
ありがとうございました。はじめ紹介をしないとすみません。ごめんなさい。大変失礼しました。Now the presentation is open for the questions and discussions. So, any comments 必要とあればぜひ良い機会ですので、お願いします。So, Johan, thank you very much. So you demonstrated the open design flow at the RISC-V last year, right? Right? 彼ここで自分の PC 使って、もちろん全部ではないんですけど、さっきちょろっとお見せしてたこの合成して P&I でやってっていうの一部をここでやってみせてくれました。10分ぐらいでかなりできまして、私非常に驚きましたけど、本当にできてるんだという感じですね。Do you have any suggestion to what to make?
So I think what I encourage people to do is to look at the project.
You can use here.
To the project that have been submitted to the shuttle until now. There is around 500 projects. To find a project that you like and to try to modify it. It's often what people do with software, and I think it can also work with hardware too. And so, for example, like the small 8-bit processor that the student from Japan submitted to the product, like I think it's a perfect way for other students to learn how to design a CPU, and they could like maybe start by adding a new instruction to the CPU, and start from there, not to have to start everything from scratch. And there is like another tool that we are demonstrating outside on the booth called SiliWiz that allow you to manufacture, design like devices from scratch by drawing the silicon layer all inside the web page. And so that's another example of a tool that started from the community. And I think it's a perfect way to get started with those tools.
ヨハンと重田様、どうもありがとうございました。